To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to continue with the lesson Electrochemistry. And in the previous two lessons, you were able to understand how an electrode functions when zinc was dipped in sulfuric acid. Then in the previous chapter, we discussed an electrochemical cell where the electrodes were zinc and copper. So if you recall the new terms that we discussed there, now you know what is oxidation. When a species loses electrons, we call it oxidation. And always oxidation takes place at the anode. And there, when the species loses electrons, since the electrons remain in the anode becomes negatively charged. The same way, when species gains electrons, we call it reduction. And the species gains electrons, undergoes reduction. The electrode where the reduction takes place, it is known as the cathode. And because the species takes up electrons from the cathode becomes positively charged in an electrochemical cell. And thereafter you were able to understand what half ionic equations are. Then we wrote the balanced ionic equation, which is also the cell electrochemical equation of the cell. And then you are familiar with the balanced chemical equations. So all those related to the electrochemical cell where the electrodes were zinc and copper were discussed. And by now you all know how to identify the anode and cathode based on reactivity. So now we are going to look at another electrochemical cell where we use iron and copper. So activity, let us consider a cell constructed using iron and copper electrodes. So again, an electrochemical cell with two electrodes, iron and copper. So to understand how this works, we will first do the activity. To do the activity, we have these materials, or we need these materials. Here you can see we need a beaker. Then we need dilute sulfuric acid, dilute sulfuric acid. Then here we will need iron and copper. So you all know when they need to be electrodes, it has to be a metal sheet. Iron sheet, copper sheet, or iron rod and copper rod, or an iron plate and a copper plate. Because you all know we don't put the electrodes completely into acid. Part of it has to be above the solution so that we can connect them with the conducting wires. And also we need the connecting wires. Connecting wire, or the conducting wire we can say. Connecting wire. In addition to that, to observe the current flow, we can use an ammeter, or we can use a center zero galvanometer. Center zero galvanometer. So these are the materials: beaker, dilute sulfuric acid, iron sheet, copper sheet, connecting wires, ammeter, or the center zero galvanometer. So what do? We connect the iron and copper sheets with the ammeter or the galvanometer using the connecting wires. At the same time, you take sulfuric acid into a beaker and then we dip the two electrodes into sulfuric acid. We need to observe what happens to the ammeter, and also we need to observe what happens near the iron and copper electrodes. That is how we do the activity. So I'll move on to the next slide where I discuss the method again. So the method. Now this is what we do. We have the beaker here. Beaker, with dilute sulfuric acid, or you can mark the beaker separately and sulfuric acid. This is the iron metal, and here we have copper metal, and then what are these arrows corresponding to? Now you all know from experience that you need to use the activity series in order to identify the anode and cathode. So already you all can predict. Now out of iron and copper, which is more reactive? You all know the order of elements, metals in the activity series. Iron is above copper in the activity series. If you recall the activity series again, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, then we have tin, lead, hydrogen, and then only we have copper. So iron is above copper in the activity series. So that means iron is the most reactive metal compared to copper. More reactive compared to copper. So iron will act as the anode. So here iron will act as the anode where oxidation takes place, and because of that it will become negatively charged. And copper will act as the cathode where reduction takes place and it will become positively charged. So that is something you can predict. And also in addition to this, like I told you all, we can have an ammeter connected here. It can be either an ammeter or a galvanometer, or we can have a galvanometer there. So ammeter or galvanometer can be connected there. So this is how we set the apparatus for the activity. You take the beaker, into that we take dilute sulfuric acid. At the same time you have the iron metal and the copper metal sheets, rods or plates. You connect them using the connecting wires. Connecting wire. These are the connecting wires. And also you can connect an ammeter or a galvanometer, and then you dip that into the dilute sulfuric acid solution. So if you look at the steps there. Connect the iron strip and the copper strip to the ammeter using connecting wires as shown in the figure. Then immerse the two metal strips in the beaker containing dilute sulfuric acid. Record your observation. So you all know what to do. Let's go to the lab and do this activity now. Okay students. So now these are different types of electrochemical cells. When I say different types, you can change the metals that we dip in sulfuric acid. So to understand that, here I have sulfuric acid, then I have two metals. You all can see this is an iron nail. So one metal is going to be iron, the other metal is copper. And both are connected to the galvanometer. So you can see the deflection of the galvanometer as well as you can see the direction of the current flow as well. So far you all are familiar with what happens in an electrochemical cell. There is a chemical reaction taking place, and due to the chemical reaction there is flow of electrons. That means there is a flow of current. And you all know always electrons flow from the negative terminal to the positive terminal, and current, that is the conventional current, flows from the positive terminal to the negative terminal. And you are familiar with the half reactions or the half ionic reactions. The oxidation reaction is where a species loses electrons and becomes either a positive ion. So here a metal loses electrons and becomes the positive ion. So that is an oxidation reaction, and where oxidation takes place is known as the anode. And when a species takes up electrons and becomes the product. Say for example, H plus ions taking up electrons and becoming H2 gas. That is a reduction reaction. And reduction reaction occurs at a metal electrode, and that electrode is known as the cathode. And from the previous activity, you all can remember, students, the cathode is positively charged and anode is negatively charged. Now we have both iron and copper electrodes. First we will see what happens when we dip those two in sulfuric acid. So I am going to dip the two electrodes into sulfuric acid, copper and iron. Now you saw the deflection of the galvanometer. Here you can see how it deflects. And also you will see observations near the two electrodes. We will have to wait for some time. When you put the metal rods or metal plates into the solution, we have to make sure that the metals do not touch each other. They have to be dipped in the solution. We will have to wait for some time to see the change. So here also, from the deflection of the galvanometer, you all know current flows from copper to iron. At this point, students, recall the activity series. In the activity series, you all know iron is above copper in the activity series. That means iron is more reactive than copper. So because of that, when we have iron and copper, iron will dissolve. Iron will get oxidized. That is, Fe atoms lose electrons and become Fe2+. So there, the iron nail will become the negative electrode, and that is the anode because oxidation takes place there. At the same time, H plus ions from sulfuric acid will migrate towards the copper metal, and from there H plus will take up electrons and become H2 gas. So here, students, can you all see the gas bubbles evolving near the copper plate? So there what happens? H plus ions from sulfuric acid, because sulfuric acid dissociates and H plus ions are released. H plus ions come near the copper metal. There they take up electrons from copper and get converted to H2 gas. So that is what you can see as the gas bubbles near the copper plate. But iron acts as the anode. So students, you all can see now near the iron you don't see any gas bubbles. So iron nail acts as the anode. There iron dissolves. So iron gets converted to Fe2+ ions and it goes into the solution, leaving the electrons in the iron nail. So there iron becomes negatively charged, and because it is oxidation, iron is the anode. And near the cathode, H plus ions from the solution come towards the copper plate, and there they take up electrons and get reduced, and that is why you can see the evolving of gas bubbles. So there it is a reduction reaction. The copper metal acts as the cathode and that becomes positively charged. So in an electrochemical cell, cathode is positively charged, anode is negatively charged. And when we use copper and iron, copper is the cathode and iron is the anode. So those are the observations. So now you all can understand that, students. So here we use two different metals, iron and copper. In the activity series, you all know iron is above copper in the activity series. That means iron is more reactive than copper. So there, iron, because it is more reactive, it acts as the anode. It undergoes oxidation, whereas copper is less reactive, so it does not undergo oxidation. So there will be reduction taking place near cathode, that is copper. Because copper is less reactive, it is reduction near the copper electrode. Iron is more reactive, so there is oxidation taking place near the iron metal. Is that clear to you? So always remember, students, when we take two metals as electrodes in an electrochemical cell, the more reactive metal becomes the anode. It dissolves and it undergoes oxidation reaction. Therefore, it acts as the anode. The less reactive metal, near that it is the reduction taking place, and therefore the less reactive metal becomes the cathode. And also the cathode is positively charged and the anode is negatively charged in an electrochemical cell. So those are the things that you all have to understand. Then after this, we will discuss the half ionic reactions. That is the reduction half reaction and the oxidation half reaction taking place near the cathode and anode respectively when I discuss the observations with you all. Okay, students. So you were able to observe the changes clearly. What happens when we use iron and copper as the electrodes in an electrochemical cell? What were the observations? You were able to see the deflection of the galvanometer. If we had an ammeter also, you would have seen the deflection. So here, since it was the galvanometer, it was easy for you all to observe the direction of the deflection. And then, you were able to see that the iron electrode dissolves and there are gas bubbles being evolved near the copper electrode. So those were the observations. So here, if I write the observations, iron electrode dissolves gradually. Gas bubbles evolve near the copper electrode. So here, of course, students, I will write the observation for both ammeter and galvanometer so that you will remember how to write it. So, deflection in the ammeter confirms the flow of current. Otherwise, you have to say about the galvanometer. There is deflection in the galvanometer indicator moves from copper side to iron side. So from that, what can you understand? Current flows from copper to iron. Copper is the cathode, the positive electrode. Iron is the anode, the negative electrode. And electric current, conventional current, flows from positive to negative. Copper to iron. So you have to remember that. So from this, we can get some conclusions. Conclusion. Can say conventional current flows from copper to iron iron, and also we already know iron is the anode where oxidation occurs. Copper is the cathode where reduction occurs. And iron is the negative electrode, and copper is the positive electrode. So, although I have said conclusion, now conventional current flows from copper to iron, that you get from the observation. So, therefore, you know copper has to be the positive electrode and iron has to be the negative electrode. But the same thing we were able to predict using the activity series based on their reactivity. So, there you know iron is the anode where oxidation takes place or occurs because iron is more reactive than copper. Copper is the cathode where reduction occurs, and also iron is the negative electrode and copper is the positive electrode. So, what are the reactions taking place? So, like earlier, before writing the reaction separately, first we will try to understand what happens in the electrochemical cell. So, we have the galvanometer, dilute H2SO4, it divides to H plus aqueous and SO4 minus aqueous because it is a strong acid. Then we have copper and iron solid. So, what happens here? Now, in this, iron is the more reactive one. So, therefore, iron becomes Fe2 plus aqueous, losing 2 electrons. So, that is the oxidation. And because of that, it is the anode. And when oxidation occurs, Fe2 plus go into the solution. At the same time, electrons remain on the metal strip. Because of that, it becomes the negative electrode. And on this side, the H plus ions that are there in the solution go towards the copper, and near the copper, H plus ions take up electrons. H plus aqueous takes up electrons and becomes H2 gas. So, that is a reduction reaction. This is reduction. Therefore, copper is the cathode. And because H plus ions take electrons from copper, copper becomes positively charged. And then what happens? Electrons flow from iron to copper. Conventional current flows from copper to iron. Electrons flow from iron to copper, while the conventional current flows from copper to iron. I is the current. So, how does the galvanometer deflect? It deflects towards the iron electrode, from copper towards the iron electrode. So you will see a deflection towards this side. That is the advantage of using the galvanometer. Is that clear to you all? Can you all understand this, students? So this is how the electrochemical cell using iron and copper electrodes function. You all have to remember the half equations, half ionic reactions, oxidation half ionic reaction, reduction reaction, and the balanced ionic equation or the electrochemical reaction. Is that clear to you all? So now that I have summarized all the changes, if you look at it again, iron is more reactive, so it gets oxidized to Fe2 plus aqueous, losing electrons. Electrons remain on the electrode. So because of that, the anode becomes negatively charged. At the same time, H plus ions from the solution move towards the copper electrode, where they take up electrons from copper, get reduced. Because of that, copper becomes the cathode, and because copper gives the electrons to hydrogen ions, copper becomes positively charged. And then electrons flow from iron to copper, current flows from copper to iron. So these are the observations, the conclusion, and this is the concept or the reactions taking place in an electrochemical cell that has iron and copper as the electrode. I am sure you all can understand this. So with this, I'll move on to the next slide, where again we will be writing down the reactions and the equations. So in the activity series, iron lies above copper. So that you know, in the activity series, iron lies above copper. Therefore, what is subjected to oxidation and act as the anode is the more reactive metal, iron. Very important. So, oxidation, anode is the more reactive metal, iron. So, based on that, if we write the reaction here, iron solid becomes Fe2 plus aqueous, losing 2 electrons. And here we will take this as the third equation, because so far in the previous chapter we have been using the reactions of zinc and copper as 1 and 2. So to avoid confusion, we will take this as the third equation. So the reaction of copper again will become the fourth equation. Since iron atoms dissolve into the solution, leaving electrons on the iron strip, it is negatively charged relative to copper. Thus, iron electrode is the negative terminal of the cell. So that is also important. So here you can see iron atoms dissolve into the solution, leaving electrons on the iron strip. It becomes negatively charged. It is negatively charged relative to copper. Thus, iron electrode is the negative terminal of the cell. So that is what we have already discussed. So then, in the next slide, in this cell also, the following reduction half reaction. Now, I introduce this term to you all. Reduction half reaction occurs at the less reactive copper metal. Therefore, copper electrode acts as the cathode of this cell. So, here, what is the reaction? Now, copper we have, if we write the equation near copper, 2H plus ions aqueous takes up electrons from copper and become H2 gas. This is the reduction. Near copper, H plus aqueous takes up electrons from copper and get reduced to H2 gas. So that means copper metal acts as the cathode. Electrons flow to the copper electrode across the external wire. Therefore, copper electrode is the positive terminal of the cell. So that is also something you need to remember. electrons flow to the copper electrode across the external wire. Therefore, copper electrode is the positive terminal of the cell. So students, this is how the reaction takes place at the copper electrode. And the copper electrode becomes the anode and it is positively charged. So current flows from anode to cathode. Positive electrode to negative electrode. So that is copper to iron here. So those are the reactions. Now we will look at the chemical equation, that is the electrochemical equation of the cell. To that, I'll move on to the next slide. The overall ionic reaction of the cell can be obtained by adding the two half reactions 4 and 5. Now here students, in the textbook, like I told you all, to avoid confusion, we are using different numbers. But since I had 1 and 2 in the previous chapter, I numbered the first reaction, that is the oxidation half reaction, as 3. But in the textbook, they have taken it as 4 and 5. So because of that, I'll go back to the slide and make it as equation 4. So here, this will be the fourth equation. You have to remember number 3 has been skipped. That is not a problem. This is just for you all to identify the reaction, students. So the oxidation half reaction becomes the fourth reaction. And near the copper electrode, the reduction half reaction becomes the fifth reaction. So then in the next slide, here you can see 4 and 5. The two half reactions, 4 and 5. What do we get? When you add them together, now you remember here the metal is iron. Iron solid plus we have 2H plus aqueous taking up 2 electrons, giving rise to Fe2 plus aqueous, and we have 2 electrons plus H2 gas. And in that, you all know, because electrons are there on both sides of the equation, we can cancel them off. So here, we can cancel off the electrons. Then you will get the balanced ionic equation or the overall ionic reaction. Overall ionic reaction, that is going to be Fe solid plus 2H plus aqueous, giving rise to Fe2 plus aqueous and H2 gas. Is that clear, students? So when a current is drawn from the cell, it can be observed that the iron electrode dissolves and gas bubbles evolve at the copper electrode. So that is also something you have to remember. When a current is drawn from the cell, it is observed that the iron electrode dissolves and gas bubbles evolve at the copper electrode. Is this okay, student? So finally, if you want to write the balanced chemical equation, what do you need to consider? Now from sulfuric acid only we got the H plus ions. So the sulfate ions from sulfuric acid are still there in the medium, the solution. So that will combine with H plus as well as Fe2 plus. So the overall reaction, balanced chemical equation can be written as this: Fe solid plus H2SO4 aqueous Y H plus ions plus sulfate ions will give rise to FeSO4 aqueous plus H2 gas. So that is the balanced chemical equation that you can get. So this is the overall ionic reaction of the cell can be obtained by adding the two half reactions. What is the oxidation half reaction? Fe becoming Fe2 plus, losing electrons. Reduction half reaction, H plus taking up electrons, becoming H2 gas. When you add them together, you get this equation. Fe solid plus 2H plus aqueous plus 2 electrons giving rise to Fe2 plus aqueous, 2 electrons and H2 gas. But in that, you can cancel off the 2 electrons from either side. Then we get the equation as Fe solid plus 2H plus aqueous giving rise to Fe2 plus aqueous and H2 gas. That is the overall ionic reaction or the electrochemical reaction or the balanced ionic equation. So here students, we are using different terms, but they all refer to the same equation. Then, when a current is drawn from this cell, it can be observed that the iron electrode dissolves and gas bubbles evolve at the copper electrode. So that was the observation. And also you were able to see how current flows. Current flows from copper to iron. Electrons flow from iron to copper. And also, if you write the balanced chemical equation, it is going to be this way. Balanced chemical equation, Fe solid plus H2SO4 aqueous giving rise to FeSO4 aqueous and H2 gas. So, this is the balanced chemical equation. And you have to remember, students, so if we summarize, here iron more reactive, so it is oxidation, anode and becomes the negative electrode. At the same time, copper less reactive, so there will be reduction taking place and therefore it is the cathode and it becomes positively charged. So these are all information that you have to remember. And you have to remember electrons flow from iron to copper and conventional current flows from copper to iron. Is that clear, students? Here, iron is the negative electrode, copper is the positive electrode. So, electrons flow from iron to copper and the conventional current flows from copper to iron. Is that clear to you all, students? So, these are the reactions related to an electrochemical cell constructed by using iron and copper as the electrodes. I will quickly go back and look at all the reactions again for you all. We will go back to the slides and we will quickly have a look at the reactions. Now this is the electrochemical cell, students. You can remember I drew this to explain everything to you all. We have the beaker containing dilute sulfuric acid. It dissociates to form H plus and SO4 2 minus ions. At the same time, because iron is more reactive, it undergoes oxidation, losing electrons on the electrode and Fe2 plus ions go into solution. So because of that, this becomes the negative electrode. So iron undergoes oxidation and becomes the anode, and also it becomes negatively charged. At the same time, H plus ions from the solution go towards the cathode. They take up electrons from the cathode and get reduced to H2 gas. Because reduction occurs at the copper electrode, it becomes the cathode. And then, because electrons are taken from copper, copper becomes positively charged. So that is this. And electrons flow from negative to positive charge, that is from iron to copper. At the same time, the electric current, conventional current, flows from copper to iron, that is from positive to negative. So if we have a galvanometer, from the direction of the deflection, we can confirm this. That is what I did in the lab also. So you were able to see those. And the observations: dissolving of the iron electrode, gas bubbles evolving near the copper electrode, and the deflection of the galvanometer, or if you had the ammeter also, you will see the deflection, but there of course you cannot judge the direction. That is something you have to remember. So then we discuss the reactions. The oxidation and anode is the more reactive metal, iron. So here Fe solid dissolves or undergoes oxidation, that is forming Fe2 plus aqueous and releasing electrons. Because the electrons are left on the electrode, it becomes negatively charged. Then we saw that near the copper, H plus ions get reduced to form H2 gas. And because electrons are taken from copper, copper becomes positively charged and it is the cathode. So positive terminal of the cell and it is the cathode. Then we got the overall reaction, and just remember the numbering 4 and 5. Oxidation is the number 4 reaction and reduction is number 5. So here the overall ionic equation is Fe solid plus 2H plus aqueous, giving rise to Fe2 plus aqueous and H2 gas. That is the overall ionic reaction. And then I showed you all the balanced chemical equation also, including the sulfate ions that are there in the medium, because we get H plus from sulfuric acid. And here again, to summarize, these are the things you have to remember. Iron more reactive, so oxidation occurs there and it becomes the anode and negative terminal. Copper is less reactive, reduction occurs there and it becomes the cathode and it is the positive terminal. And electrons flow from iron to copper, that is negative to positive, and conventional current flows from copper to iron, that is positive to negative. So that students, you all have understood what happens when we use iron and copper as the electrodes in an electrochemical cell. Next, I will discuss another electrochemical cell where we use iron and zinc as the electrodes. So then I'll move on to the next slide. So activity, let us consider a cell constructed using zinc and iron electrodes. So this is the method what we will be doing. We need to take a beaker containing dilute sulfuric acid. So this is going to be dilute H2SO4 sulfuric acid. And in that we will be using 2 metal strips or metal plates. One is going to be zinc. The other one is iron. And in this, you will see zinc will be the negative electrode and iron will be the positive electrode. We will try to understand that. So we have a beaker, inside that we take dilute sulfuric acid. In addition to that, we have zinc and iron connected by conducting wires. And then when you immerse them into the dilute sulfuric acid solution, you will get the observations. So from that we can explain the activity of this particular cell. So this is the method. Connect the zinc strip and the iron strip to the ammeter using connecting wires as shown in the figure. So in addition to this, we can also have an ammeter there. Here we will have an ammeter. So that will be connected so that you can observe the current flow and the direction of the current flow. Like I have told you all before, students, instead of an ammeter, we can also use a galvanometer, a center zero galvanometer, where you can observe the direction of the current flow as well. Based on the direction of the deflection, you can understand the direction of the current flow. But if we use an ammeter, you will observe that it is the current flow that is taking place. Or else we can also use a light bulb. If you use a light bulb connected instead of an ammeter, you will see the bulb light. Then you can confirm there is current flowing through the external circuit. So either way, we need to observe that there is current flow. So connect the zinc strip and the iron strip to the ammeter using connecting wires as shown in the figure. Then immerse the two metal strips in the beaker containing dilute sulfuric acid and record your observation. So you are familiar with these types of activities. So let's go to the lab and do the activity now. Okay, students. So this is the third electrochemical cell that you are going to observe. Here again we have dilute sulfuric acid as the solution, and then I have the galvanometer, and here you all can see I have two different metals. One is iron, the other one is zinc. So when you compare the reactivity of iron and zinc, you all know iron is less reactive than zinc, or zinc is more reactive than iron, and in the activity series also zinc is above iron. So from the previous activities and the observations, now you all can understand, students, the more reactive metal, so that is zinc, will undergo oxidation. Therefore, that will become the anode, and also that will be negatively charged. And iron, which is less reactive compared to zinc, will undergo, or the reaction that happens near iron will be the reduction reaction. Therefore, iron will be the cathode and iron will become the positive electrode. So, you are familiar with all those. So, the current flows from positive terminal to negative terminal. That can be observed from the deflection of the galvanometer. And also you can see the other observations as well. So, here I am going to dip the two electrodes into the solution. You can see the observation of the galvanometer, how the indicator deflects, and the observations near the electrodes. So, this is zinc and iron. So, now I have inserted both the metals, zinc and iron, into the sulfuric acid solution. So, as you know, zinc is more reactive, so that has to undergo oxidation. The zinc plate will dissolve. It will react with sulfuric acid, it will dissolve, and it will become negatively charged. And iron, near the iron, because iron is less reactive than zinc, near the iron, hydrogen ions undergo reduction. So, can you all see? Near the iron nail, you can see the gas bubbles. So, those are the hydrogen gas bubbles. And also, you will be able to see that the zinc metal dissolves. And from the galvanometer, you can see the current flows from iron to zinc. Iron acts as the positive electrode, zinc acts as the negative electrode. Iron is the cathode and zinc is the anode. So, their current flows from iron to zinc. That is how the galvanometer deflects. That you can understand. So, these are the observations, students. Near the iron nail, you see gas bubbles evolving, that is hydrogen gas. Zinc metal will dissolve. So, zinc will be the anode. It will be negatively charged. Iron will be the cathode. It will be positively charged. And current flows from iron to zinc. That is how this particular electrochemical cell works. So, from these, students, From all three activities, we use different metals, different combinations of metals. So, first thing you have to remember the activity series. Which metal is more reactive? The more reactive metal acts as the anode because it undergoes oxidation. So, here zinc is more reactive than iron. Zinc undergoes oxidation, it becomes the anode and it becomes negatively charged. At the same time, since iron is less reactive, hydrogen ions, H plus ions come towards the iron and there it takes up electrons from iron metal and it gets reduced. Hydrogen H plus ions get reduced by taking up electrons from the iron metal. So, their iron metal or the iron nail acts as the cathode. So, you were able to see gas bubbles evolving near the iron nail and you were able to see the direction of the current flow as well. So, from this, you all can understand the way the electrochemical cell functions when we use iron and zinc as electrodes. Okay, students. So, I am sure you all were able to see the observations clearly. What did we see during this activity? Now, you were able to see that the zinc plate dissolves and also you were able to see the gas bubbles evolving near the iron electrode and also you were able to see the deflection in the galvanometer. So, from the deflection, you were able to see the direction of the current flow. So, you can understand that current flows from iron to zinc. In addition to that, I mentioned that there also you were able to see some gas bubbles evolving near the zinc electrode. That is because of the reactivity of zinc and iron. In the activity series, you all know zinc is above iron in the activity series. That means zinc is more reactive. So, because of that reactivity, there is a certain amount of reaction between zinc and sulfuric acid also taking place. But here, we don't need to consider that particular observation. So, the observations of the electrochemical cell, you were able to see the zinc strip dissolves, then gas bubbles liberated near the iron electrode and also deflection in galvanometer. So, here as a note, I will write this. Galvanometer, direction of current can be observed. Current flow can be observed, but in ammeter only the current flow can be observed. Also, a light bulb can be used instead of the above. So, this is a note you all have to remember, students. In all the activities, you can use an ammeter or a galvanometer or a light bulb so that you can observe that current flows through the external connecting wires or external circuit. So then only you can confirm that the electrochemical cell is functioning. From the chemical reaction, electricity is being produced. So that is what we are trying to understand here. So like we discussed before, students, why do we see these observations? So here, if I draw the electrochemical cell again, we have the two metals, then we have the ammeter connected by the connecting wires. So this is dilute sulfuric acid. Then here we had iron, here we had zinc. So what happens here? Now if you consider the reactivity, this is the ammeter that we connected. So there is a deflection in the ammeter or the galvanometer. And here, what do you think happens? Now zinc is more reactive than iron. So here you have to remember that zinc more reactive than iron, reactivity. So here, if you consider the reactivity, students, zinc is more reactive than iron. So because of that, zinc will undergo oxidation. So zinc electrode, zinc solid becomes zinc 2 plus aqueous, losing 2 electrons. So there what happens? When it loses electrons, the zinc 2 plus ions go into the solution, leaving the electrons on the zinc plate. Because of that, the zinc plate becomes negatively charged. So this is negatively charged. And there, this is the losing of electrons. Zinc losing electrons forming zinc 2 plus ions. So what is that reaction? It is an oxidation reaction. This is oxidation. And you all know by convention, oxidation takes place at the anode. So here, zinc is the anode. So zinc is the negative electrode. Oxidation takes place there and it is the anode. At the same time, what happens on the other side? Here, near the iron electrode, the H2SO4 normally dissociates to give rise to H plus aqueous plus SO4 2 minus aqueous. Now this is also the aqueous solution. So out of these, the H plus ions travel towards the iron electrode. There what happens? 2 H plus ions, H plus aqueous, take up electrons forming H2 gas. What type of a reaction is this? This is reduction. So reduction takes place at the cathode. And because H plus ions take up electrons from the iron electrode, this is iron electrode becomes positively charged. This is positively charged. So that is the observation you see there. So if you look at it, if you try to understand, near the zinc electrode, zinc is more reactive, it undergoes oxidation, loses electrons, forms zinc 2 plus ions that go into the solution. So there it is oxidation and therefore zinc is the anode, and because zinc leaves electrons in the metal, it becomes negatively charged. At the same time, near the iron strip, hydrogen ions take up electrons from iron and become H2 gas. That is a reduction reaction. Therefore, iron acts as the cathode. And since H plus ions take up electrons from iron, that is Fe, it becomes positively charged. And that is why you see gas bubbles near the iron electrode, the zinc plate dissolves, and there is current flow. How does current flow? Now here you can see negative to positive charge is the electron flow. positive to negative charge is the current flow. So from zinc to iron, electrons flow through the external conductor, and from iron to zinc, the current, conventional current, flows from iron to zinc through the external circuit. You have to understand that, student. So these are the changes taking place in this particular electrochemical cell. So in the next slide also, I will be discussing the same reactions again. So with that, students, I'll move on to the next slide. So here, in the activity series, zinc metal is placed above iron. Therefore, zinc, which is more reactive metal, undergoes oxidation and acts as the anode. Reaction at the zinc electrode or the anode, zinc solid forms zinc 2 plus aqueous by losing 2 electrons. And this is one particular reaction. Here too, as the zinc atoms dissolve into the solution, leaving electrons on the zinc electrode, zinc becomes negatively charged relative to iron. So all what I explained to you all. Zinc atoms dissolve into the solution, leaving electrons on the zinc electrode, zinc becomes negatively charged relative to iron. For this reason, zinc electrode becomes the negative terminal of the cell. So zinc electrode becomes the negative terminal of the cell. Is that clear, student? So then I'll move on to the next slide. Then reaction at the iron electrode. So what happens near the iron electrode? 2 H plus ions, H plus aqueous, taking up 2 electrons, forming H2 gas. Because reduction occurs at iron, it acts as the cathode. So because reduction occurs at iron, it acts as the cathode. Electrons flow towards the iron electrode along the connecting wire. Hence, iron electrode is the positive terminal of the cell. So this is also something you have to remember. Electrons flow towards the iron electrode along the connecting wire. Hence, iron electrode is the positive terminal of the cell. So these are the two reactions. This is the reduction half reaction and the previous one is the oxidation half reaction. And when you add them together, what do we get? We get the complete cell reaction or the overall cell reaction. I will write that in the next slide. The overall ionic reaction of the cell can be obtained by adding the reaction 6 and 7. So here in this, we can label this as the 6th reaction, that is the oxidation of zinc. And then we have this reduction of hydrogen ions as the 7th reaction. In both, you all know there are only 2 electrons involved. So we don't have to multiply any of the half ionic equations in order to balance the reaction. We can directly add them together. So in the next one, when we add the 2 reactions, 6 and 7, what do we get? We have zinc solid plus 2H plus aqueous, giving rise to zinc 2 plus aqueous and H2 gas. Here on either side there are 2 electrons, they get cancelled off. You all can remember that. When this cell operates, we will be able to see that the zinc electrode dissolves and gas bubbles evolve at the iron electrode. So you can see when this cell operates, we will see that the zinc electrode dissolves and gas bubbles evolve at the iron electrode. And that is the overall cell reaction. And how does electron flow? You will see electrons flow from zinc, that is the negative electrode, to iron, that is the positive electrode. At the same time, conventional current flows from iron, positive electrode, to zinc, that is the negative electrode, through the external circuit. So that is how the electrochemical cell functions. So up to now, students, we have discussed 3 different electrochemical cells: zinc and copper, then copper and iron, and now iron and copper. In all these, you would have observed the common features of the electrochemical cell. Where the oxidation takes place, it is the anode, that is a convention, and you have seen in the electrochemical cell, anode is the negative electrode. And where the reduction takes place, that is the cathode, becomes the positive electrode. And always, when we draw the electrochemical cells, you would have noticed that we always draw the anode or the negative electrode on the left-hand side. And that is the more reactive metal compared to the second metal. So just to recall all that and to understand this, here students, if we take all 3 cells, I'll draw the cells and explain all 3 at the same time. So these are the 3 cells that we constructed. Now first one, zinc and copper. Then we had iron and copper, and now zinc and iron. In all 3, you can see when you take zinc and copper, zinc is more reactive. That is conventionally or normal practice is to draw the more reactive metal on the left hand side, less reactive metal on the other side. So this is the negative electrode and that is the anode. Here this is the positive electrode and cathode. When you take iron and copper, there what happens? Iron is more reactive than copper, and iron becomes the negative electrode and it is the anode. And here you have copper, the positive electrode, which is the cathode. Then we have zinc and iron. In that, zinc is the negative electrode and that is the anode. And iron becomes the positive electrode, which is the cathode. So can you all understand the relationship there? Always, first we draw the more reactive metal. On the right side, we draw the less reactive metal. The more reactive metal acts as the anode undergoing oxidation and it becomes the negative electrode. And the less reactive metal acts as the cathode where the reduction takes place and that is the positive electrode. And always the current flows from positive to negative and electrons flow from negative to positive. So here zinc to copper electron flow, copper to zinc current flow. Like that, you should be able to identify the reactions in all three electrochemical cells. Here, negative to positive electron flow, positive to negative current flow. Here also zinc negative, from that to iron positive electron flow, from iron to zinc it is the current flow. So now you all can understand the similarities between the three electrochemical cells. And in this, you can understand, we said, by a chemical reaction, electricity is generated. That means chemical energy is converted to current, electric energy. That is the energy conversion taking place in all these cells. In an electrochemical cell, from chemical energy, electric energy is produced. Or you all can remember, by the chemical reaction, there is electricity generated. So this is a normal cell, a simple cell, but if you use it in different ways, we get the dry cells and the other forms of cells. They are all electrochemical cells. And in an electrochemical cell, there is always oxidation and reduction taking place. During oxidation, a species loses electrons, and those electrons have to be taken up by another species that undergo reduction. So oxidation and reduction together will give you the overall cell reaction. So I'm sure students, you all can understand the working of all these three electrochemical cells. So with that, I'm going to end this chapter, and in the next chapter, I will discuss another topic, that is electrolysis.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.